Have you ever wondered how time behaves in space? Does it tick the same way as it does here on Earth? The concept of time in space is a fascinating one, and not quite as straightforward as you might think. You see, time is relative. It's influenced by gravity, and different gravitational forces can impact the flow of time. This is a concept known as gravitational time dilation. Simply put, time moves slightly faster in places with lower gravity. Now you might be thinking, how much of a difference can that really make? Well, when we're talking about the precision needed for space missions, even the smallest discrepancies can have significant impacts. For instance, due to the moon's lower gravity, time moves slightly faster there than on Earth. This difference amounts to about 58.7 microseconds within every 24 Earth hours. While this might not seem like much to us for the delicate operations of satellites and space stations, it's a discrepancy that can't be overlooked. These small time differences caused by gravitational effects can impact the synchronization of satellites and space stations. And in the vast expanse of space, where precision is key for successful operations, these time discrepancies need to be addressed. So how do we go about solving this problem? The answer lies in a novel initiative that's been undertaken by none other than NASA. The United States government tasked NASA with establishing a standard time zone for the moon. This is known as Coordinated Lunar Time, or CLT. But what does CLT entail, and how will it change the future of space exploration? Well, that's a story for the next scene. So to address these time discrepancies, a novel initiative has been undertaken: the establishment of a standard time zone for the moon, known as Coordinated Lunar Time, or CLT. The United States government recently tasked NASA with a unique mission to establish a standard time zone for the moon. You may wonder why a celestial body with no human population requires a time zone. The answer lies in the growing interest in lunar exploration and the need for precise coordination of missions on the moon's surface and those operating in the vicinity, known as cislunar space. This initiative, termed Coordinated Lunar Time, or CLT, is essentially about synchronizing timekeeping for these lunar missions. But why is that important? Well, maintaining precise time synchronization is crucial for successful operations in space. This is especially true when it comes to precision navigation and scientific measurements during lunar missions, where even the smallest discrepancy can lead to significant consequences. But CLT is not just about timekeeping on the moon. It's about ensuring that lunar time remains in sync with Earth's time zones. To make this happen, CLT will be traceable to Coordinated Universal Time, or UTC, which is the time standard used across the globe. Moreover, CLT is designed to operate independently of Earth. Even if communication is lost, this resilience ensures that lunar missions can continue functioning without relying on Earth-based timekeeping systems. So, even if astronauts on the moon lose contact with mission control, they can still keep time accurately. In fact, NASA intends for CLT to be scalable to other space environments beyond the Earth-Moon system. This means that future space stations or missions beyond the moon could also adopt CLT as their time standard. Imagine a time standard that transcends our planet, facilitating exploration and possibly habitation of other celestial bodies. However, establishing this lunar time zone is not without its challenges. One such challenge is the effect of gravitational time dilation. Due to the moon's lower gravity, time moves slightly faster there than on Earth. CLT accounts for this effect to maintain accurate timekeeping. CLT is not just about keeping time, it's about ensuring smooth operations and successful missions on our celestial neighbor. It's about setting the stage for a future where humans venture beyond Earth, not as visitors, but as explorers, scientists, and maybe, just maybe, as residents. So how does CLT work, and why is it so critical for lunar missions? Well, let's dive right in. In its essence, Coordinated Lunar Time, or CLT, is designed to be traceable back to our earthly timekeeping standard, Coordinated Universal Time, or UTC. This traceability is crucial because it ensures that lunar time remains in sync with Earth's time zones. Imagine trying to coordinate a teleconference between Houston and a lunar base without this synchronization. It would be like trying to set a meeting between New York and London without accounting for the 5-hour time difference. Not very practical, right? But CLT isn't just about making sure we're all on the same page when it comes to time. It's also about precision navigation and scientific measurements. When we're dealing with the vast distances of space, even the smallest discrepancy in time can lead to significant errors in navigation and data collection. Think about it. If a spacecraft is moving at, say, 3,000 miles per hour, a discrepancy of just 1 second can translate into a navigation error of nearly a mile. That's the difference between a perfect lunar landing and missing the moon entirely. CLT is also designed to be resilient, capable of operating independently of Earth even if communication is lost. This independence is crucial for the success of lunar missions. If a lunar base or spacecraft loses contact with Earth, they can't afford to also lose their sense of time. With CLT, they'll be able to keep time accurately, ensuring the continuity of their operations. In space, a second can make a difference, and CLT is designed to ensure every second counts. A CLT isn't just a solution for the moon, it's a stepping stone to other space environments. Imagine a future where we're not just clocking time on the moon, but on Mars, Jupiter, or even outside our solar system. NASA's grand vision for coordinated lunar time doesn't stop at the moon. It's designed to be scalable, adaptable for other celestial bodies and their unique conditions. This means that future space missions, whether they're targeting the red sands of Mars or the icy rings of Saturn, could also adopt CLT as their standard of time. But to turn this vision into reality, we need more than just sophisticated technology and scientific expertise. We need the power of global cooperation. Establishing a lunar time zone isn't a decision one country can make on its own. It requires international agreements, a shared understanding among nations that we are all stewards of the cosmos. It's a testament to how our exploration of space is not just a race, but a collective endeavor, a journey we undertake together as a species. NASA's efforts to establish CLT align with the broader goal of creating international norms for space exploration and cooperation. It's about making sure that, as we push the boundaries of human knowledge and capabilities, we do so in a way that respects shared values and principles. The clock is ticking, and NASA has a deadline to meet. By the end of 2026, around the same time as the Artemis III mission aims to land humans near the lunar South Pole, CLT needs to be up and running. It's a monumental task, but one that NASA is fully equipped to handle. So, as we look to the stars and dream of what's possible, we can be sure of one thing. Time, as we know it, is about to get a whole lot more exciting. The clock is ticking, and by the end of 2026, CLT will be a reality. Time, as we know it, is about to change in space, but what does this mean for future lunar missions? Let's break it down. The success of a lunar mission hinges on extreme precision. Every second, every minute, and every hour matters. And this is where coordinated lunar time, or CLT, really shines. It's designed to deliver the kind of accuracy that makes a difference between a successful mission and a failure. So how does CLT do this? It all comes down to accounting for a strange phenomenon known as gravitational time dilation. Due to the moon's lower gravity, time actually ticks by a smidge faster there than it does on Earth. We're talking a difference of 58.7 microseconds every 24 Earth hours. It may not sound like much, but in the world of space exploration, it's an eternity. CLT takes this into account, ensuring accurate timekeeping even in the face of this cosmic oddity. By doing so, it eliminates the risk of small time discrepancies that could potentially throw a spanner in the works of our lunar operations. But it's not just about keeping time. CLT is also designed to ensure smooth coordination between lunar craft and Earth-based systems. This is crucial for maintaining the synchronization of satellites and space stations in lunar orbit. And remember, in space, synchronization is everything. The introduction of CLT also represents a significant stride towards international cooperation in space exploration. It's a sign that we're all on the same page, working towards the same goals. And when we're talking about the vast expanse of space, that kind of unity is invaluable. So, as we look to the future, it's clear that CLT will play a pivotal role in our lunar exploration endeavors. It's more than just a timekeeping system, it's a tool that will help us navigate the final frontier with greater precision and efficiency than ever before. With CLT, the future of lunar exploration is set to be timely, precise, and successful.